Late 2023, Mistral drops a model called Mixtral 8x7b, and the benchmarks confuse everyone. It trades blows with Llama to 70B, a model 5 times larger, but its inference cost looks like a 13B model. The model card says 46.7 billion total parameters. The inference logs say only about 13 billion active per token. Reviewers asked which number was real. The answer was both, and the trick is called mixture of experts. Start with the wall that ordinary models hit. In a standard transformer, every token flows through the same feed-forward weights. If that layer has a billion parameters, every single token pays the compute cost of all of them, no exceptions. So you're trapped. You want more parameters for more knowledge, but every parameter you add costs compute on every token. Mixture of experts asks the obvious question: can you add parameters without adding the proportional compute? Here is how. Replace that one big feed-forward network with two pieces, experts and a router. The experts are several separate feed-forward networks, each with its own weights. Mixtral has 8 of them. The router is a tiny learned layer. It looks at each token and scores how well each expert suits it. Then for that token, only the top 2 experts by score fire. The token passes through those 2 networks and no others. Their outputs get blended by the router scores, and the other 6 experts, they get 0 compute for that token. That is the magic. 8 experts of 7 billion plus shared layers is 47 billion parameters that exist, but only 2 experts run per token. So the active compute lands near a 13 billion dense model, capacity of a giant, cost of a midsize. Now hear the misconception, because it is everywhere. This is not just model parallelism. Parallelism splits one set of weights across GPUs to fit in memory. Mo keeps the weights, but each token computes through only a fraction. Parallelism solves memory, Mo solves the compute versus capacity trade-off. Different problems entirely. And why does routing even work? Because the router is trained end-to-end by gradient descent with the whole model. It learns which expert handles which kind of token. One drifts toward code, another toward names or numbers. Nobody designed that. It emerges. But Mo is no free lunch. First, memory. All 8 experts must sit in GPU memory, even though only to run. Mixtral needs around 87 GB. That does not fit on a single 80 gig 100. A 13B dense model fits with room to spare. Second, load balance collapse. If the router falls in love with 1 or 2 experts, the rest never learn and go to waste. The fix is an auxiliary loss that punishes skewed usage. And third, the routing is discrete and noisy, so these models are just harder to train. Still, Frontier Labs went all in. DeepSeek, Llama 4, and almost certainly GPT-4. The bet? Decouple knowledge from compute and let the router run it.